Says, a person standing 300 feet away from a building, the angle of elevation to the top of the building is 45 degrees. What is the height of the building? So, guys, let's draw a picture, right? That was our best option, drawing a picture. So, a person standing 300 feet away from a building, so let's just draw a little rough building here, rough sketch of a building. A person is standing 300 feet away, so you draw a little person. The angle of elevation to the top of the building. So there's two types of angles of elevation, angle of depression. Can anyone remember? It's been a while back. What is angle of elevation? How do we make that angle? Yeah, very good. It's from the ground up, right? Looking up at something. Remember me standing here and saying the angle of elevation for me looking up to the flag would be this angle, right? So we know the angle of elevation is from the ground up. So this angle right here, it says is 45 degrees. So we're just drawing in a picture. Now, they're standing 300 feet away. So you guys, it's just like a real world problem. And it's how high is the building. So we put our X right here. So we know that this is, if the engineers have built the building correctly, this would make a 90-degree angle to the ground. Otherwise, that building hasn't been built correctly. So it's a right triangle, right? What are we going to do to solve for X? What are we doing? You tell me. I like that you said tangent. So we're using 45 as theta, right? We have opposite and adjacent. So way to remember that. You're right. It's right triangle trick, right, guys? That's what we're doing. So you're right. It's tangent. So we know tangent of theta is equal to adjacent over opposite over adjacent, right? Of agony, our saying goes, right? So let's put in what we know. So tangent of what? What is theta? 45 degrees, very good, is equal to our opposite side, which is x, awesome, and our adjacent side, which is, okay. Now my question is, from here, what are we doing? We're trying to get x alone. What do we do? Just math, just algebra. You said what? Okay, good. We multiply both sides by 300 because 300 is in the bottom. So multiply both sides by 300. The 300 over 300 divides out to be 1. It's x long. We've reached our goal. Yes, let's put it into our calculator. Once again, remember this. Your calculators have to be in degree mode. And once again, remember that when you guys go to take your ACT next year. So 300 tangent of 45. If it's not in degree mode, it won't calculate it, right? What'd you get? 300. Okay, very good. That's true. So it's 300 feet tall. Awesome. Way to go. Way to remember that. You will see a problem like this on your final exam on the stage, whatever you want to call it. Okay, looking at this problem. It says solve for x. Can you tell me what we're looking at here? Yeah, I like that. You're right. Tyler, you're absolutely right. We're looking at two similar triangles, right? These are two triangles that are similar. So, if we look at this, isn't this angle and this angle equal? It's called an angle bisector. Bisect means cut into two equal segments. So, what do we do to solve sides of similar triangles? We set up a what? A ratio of corresponding sides. Very good. So, tell me what my ratio is going to be. Wait. We just said, I heard this. 3 over x minus 2. Is that right? Not quite. That wouldn't be a ratio of corresponding sides. Doesn't corresponding mean it sits in the same spot, but on different triangles. We don't set up ratios on each other, right? On the same triangle, right? Say that aloud, you're right. You're absolutely right.
3 over x plus 3.
Okay, guys, 3 over x plus 3. Does everybody see how those are corresponding? Is equal to? X minus 2 over 2. Very good. So then from there, what will we do? Cross multiply. So we multiply both sides by 2, but we know algebraically over here it divides out to be 1, right? Multiply both sides by? We need parentheses, right? Everybody? Yes. Over here it divides out. This side we need parentheses. Now this is the level you are going to see on the final exam. It's testing so many things. Can you set up a proportion? Yeah, we could. Okay, so now we know, can you cross multiply? Can you solve? Yeah, we can do those two steps. So we have 6 is equal to, oh, don't we need to double distribute this? Yeah, all right, let's do that. So x times x is, so we have x squared plus 3x minus 2x minus 6. Now it's testing. Do you know how to multiply a polynomial? Yeah, we do. Okay. So we have 6 is equal to x squared plus x minus 6. Aren't we solving for x? Isn't that our goal? Now it's testing. Can you solve a quadratic? Can we? How do we do that? Yeah, we're almost to that step. 1 multiplies b, a times c adds up to b. But what's our very first step when solving a quadratic? Yes, we've got to get it set equal to 0. So what should we do? Good. Subtract 6 from both sides. So now we are reaching that 0 is equal to x squared plus x minus 12. All right, now we can go ahead and solve a quadratic. So guys, every single one of your problems, keep in mind, they're testing. Do you know everything you learned in secondary 2? I mean, they're going to test that in like 35 problems. So do you guys see how this was testing like 5 different topics that we've learned this year? Okay, that's how every single problem is going to be. But you're prepared. So a times c, what multiplies to be negative 12 adds up to be what? 1. You tell me, what are those factors?
Negative 3 and 4.
I like it. Negative 3 times 4. Does that multiply to be negative 12? No. And does negative 3 plus 4 add up to be 1? So those are truly our factors. Can we quick factor? Yeah, and if you like the long factor, that's fine. Go ahead. So doesn't this factor to be x minus 3 times x plus 4? Okay? Yeah. Quick factoring, or you drop and break, right? However you want to get there. Now, are we done? No, what do we do now? Yeah, the zero product property rule lets us set each of those equal to 0 and solve. We have x minus 3 is equal to 0. We have x plus 4 is equal to 0. So we have x is equal to 3. We add 3 to both sides. 3. Awesome. We have what? Good. So we have x is equal to negative 4. Now don't necessarily throw out both of those, any of those answers. Let's go check up here and see what we're looking at. If we plug in a negative 4 right here, isn't negative 4 plus 3 a negative 1?
Yes.
Is that going to be true? Will we have a negative side of a triangle? No. So we throw out negative 4. That doesn't mean we've done it wrong. We just throw that answer out for this problem. So our answer is x is equal to 3. Very good. You guys, so when you guys set up a true statement to solve for x and you get quadratic, you can't be scared off by that. You're going to see that almost like 80% of the time. Questions? Okay, good job, guys. Okay, it's been a while since we've done circles. Just a quick review on that, then I'll let you work. So it says, name the minor arcs, name the major arcs. Name the minor arcs, name the major arcs. It's been a little bit of time since we've done circles. So looking at this picture here, a minor arc is the arc that's made from a central angle, right? So let's name one minor arc. Any of them. Tell me what's a minor arc.
AC.
AC, true. That is very true. AC is a minor arc. Let's name a major arc that entraps the minor arc. Major arcs are named by 3, right? 3 points. Think again. Doesn't need to end at A and end at C. So we're going to be going this way. A, B, C. Right, guys? A, B, C?
Or C.
Yeah, great. That would work too. C, B, A would work. Does everybody see how it eats the minor arc? Yeah. It's around it and traps it. Okay, so we'll call it A, B, C. Look, A and C. That's how you know, come up with the same minor and major arc that go hand in hand. Okay, let's do another minor arc real quick. Do what? CB. Okay, very good. Let's quickly name the major arc around CB. Go. CAB. Is that true, everyone? Yeah. Last minor arc. AB. You're right. Awesome. So let's name the major arc around AB. Awesome. ACB. Questions? Okay, moving on. Get that picture down. Okay. It says, what is the measure of arc ABC? What is the measure of arc ABC? So I'm going to highlight that. You got to go in that order, right? ABC? So go to A, start at A, go to B, go to C. It says, what's the measure of that arc? Are these central angles? What do we know about central angles and their intercepted arcs?
It's or 2, something. Like the 30 could either be the same or.
So you're saying that this is a central angle. That is true. So what do we know about this arc? It's 30, right? Isn't a central angle equal to its intercepted arc? Yeah, you're right. So CB is 30, you're right. Very good. So then what about AB here? Good, you know it's a half circle, so this is 180 degrees. The central angle is equal to its intercepted arc, so what's arc AB? 180, okay, good. So let's go ahead and figure out what is the measure of arc ABC. Go. 210, you added up 180 plus 30. Questions? Awesome job. So guys, remember, a central angle is equal to its intercepted arc. We're almost there. Stay with me. We're only doing 2 more problems. Then the rest of the time will be yours. Okay, here we go. What is the circumference of the circle? I've seen this problem on ACTs. I've seen it on envelope testing. I see it all the time. So it says, what is the circumference of the circle? You've got to know the formula for that. What is it? We're thinking, I hear a pi r squared. Can anyone remember what that's the formula for?
The area.
Area of a circle. Way to remember that. Guys, pi r squared is the area for a circle. Close? Close? But area of a circle would be filling it in, right? Circumference means we're finding the physical distance of the outside of the circle, right? So there's 2 different ways to do it. Remember, we did learn how to find the physical distance of the outside of the circle. Isn't it radius times theta? That's one way of doing it. Also, circumference is 2 pi r, guys. 2 pi r. Remember that. 2 pi r. Or you could do it the other way we learned it, but let's go with 2 pi r. Circumference of a circle is 2 pi times the radius. So what's my radius? 4. Okay, you're right. So we have a 2, a pi, and a 4 centimeters. Let's just put 4. We'll put centimeters in our final answer. We always want to leave our answers in terms of pi, right? So what would my answer be? 8 pi's. Very good. Okay, now let's make sense of the formula, guys. Let's make sense of it, okay? If we know to find the physical distance of the outside of the circle, isn't it s is equal to radius times theta? Where theta is in radians, right? Because radians is the physical distance. So isn't this full circle makes 360 degrees? In radians, 360 degrees is 2 pi, right? So look, there is theta as, right there is theta as radians, 2 pi. Do you see that? So then times by radius, which is 4. So that's what we got, 8 pi. Questions on that? Yes.
How does the 2 pi equal what?
No, it equals 360.
6.
So remember back to when we learned how to change from degrees to radians, right? What did we say second? Degrees or radians? From degrees to radians. We said radians, so don't we put radians on top? So we put pi over 180. That's just a fancy 1. Remember how we talked about that? So if this theta is 360 degrees, and we want to switch to radians, you do 360 degrees times pi over 180, right? Right? Let's simplify that. What's 360 over 180? 2. So do you see where the 2 pi comes from? Yeah, great question, Tyler. Okay. Last one. What is the physical length of the highlighted arc? So now we're dealing with length again. What is the physical length of the highlighted arc? You will see a problem like this, every single one of you, on your final exam. Let's be ready for it. What is the length of the highlighted arc? So are we dealing with central angles? Okay, so we can figure out the measure of the arc, but I want to know the length. So we know length of an arc is s is equal to r times theta, right? Where s means length of the arc. So, looking at this picture, what's my radius? Isn't it 3? Guys?
Yes, 3.
Is it 3? Okay, so our radius is 3. If this is the middle, we know radius is 3. Now we need to know theta of the highlighted arc. So aren't we going to have to do some calculating here? Yeah, right? We know this piece is 110, right, from here to here. So let's figure out what that highlighted arc is. What would we do? Minus it from what? You're right.
110.
Minus 110 from what?
360.
Yeah, you're right. A full circle 360. So good, Tyler. 360 minus 110 degrees. So what's this left over? What's this theta?
250.
250, good. So isn't the measure of this arc 250?
Yes.
Essential angle is equal to the arc, but we want the physical length, which is radius times theta. So our theta is 250. Now, isn't our answer going to come out in degrees if we keep it like this? So don't we need to change from degrees to radians? I want physical length. If you're an engineer, you're going to use this, and you're going to change instead of degrees. You want the physical length, so you're going to change to radians. So we multiply by pi over 180. So let's all type this into our calculator. Now, multiplication order doesn't matter, so we can do this 12 different ways. So you do 3 times 250 is one way. Hit enter. Let's all practice typing it in, not just watching me. 3 times 250. Then we divide it by 180. And change it back to a fraction. What do we get? 25/6. We leave our answers in terms of pi. So S is equal to the length of the arc. The physical length is 25 pi over 6. Now that's what a mathematician would want as an answer, but an engineer would want the actual answer, the actual physical decimal. So let's type that into 25 pi divided by 6. So we'll get both answers here. 13.1, right? Guys? 13.1. Very good. So a mathematician would be happy with this answer, and an engineer would be happy with this answer. So we kind of made everyone happy here. Questions? Okay. Okay, so you're going to be doing up to page 63 on the stage test review. We are going to be having a quiz Monday. Like I said, guys, I know I've been pushing you hard. We're almost there. A week and a half left. Keep working hard for me. After that, we're going to do a lot of fun math games and stuff, okay? Push through. Go. Check off those pages with me.